All right, so the next section we'll talk about for a couple days is on something called two-way tables. And there's a couple of different, we're going to use like the same example and do some different like things with the same like information. So we have a scenario of a concert, and there were juniors and seniors that were randomly polled, and there were 106 juniors and 114 seniors that were polled about are they going to go to a particular concert. So the information was that 42 of the juniors said yes, and 77 of the seniors said yes. So to make a table, it's just kind of organizing like the information. So I'll put 11th for junior and 12th for senior, and this is yes, they're going to go, and this is no, they're not going to go. So the juniors that said yes were 42, and the seniors that said yes were 77. And then it doesn't tell you no, but it told you that 106 said yes. So if you just subtract them, 64 said no, and 37 of the seniors said no. So that's just like creating like a table, but it's going to ask you in the problem to, well, let me define a term. This is the information that is in these squares is called the joint frequency. I should have put that a little bit lower. It's a joint frequency because it kind of involves like two different like pieces of information, you know, but it's like it's a junior that said yes, it's a senior that said yes, it's a senior that said no, and it's a junior that said no. Okay, so some of the terms are, you know, going to be like important or whatever, but so then we have something called a marginal frequency. If you think about like a paper, you know, you have margins, like when you print something and you write an essay in English, there are margins. So margins, the marginal like frequency is kind of the sum of each of the, I should have maybe used some different parts for my arrows for the joint frequency, but so it's the sum of like everything. So the juniors, you already know, is 106 because it told us that, and the seniors is 114. The number of students that said yes, 119. The number of students that said no is 101. And this one over here, sorry if it's hard to read, but is 220. And if you notice, if you add the marginal frequency on the bottom, 119 plus 101 is a 220. The juniors plus the seniors is also 220. Like that should happen. Otherwise, we didn't do it right. So it says, you know, in the problem, find and interpret the marginal frequencies. So what do those blue numbers mean? The number of students who said yes. the number that said no. Total of 11th graders, total 12th graders, and just like the grand total is 220. Okay? So your first few problems are just going to be to create a two-way table. And in reality, like the first couple, they don't even give you a scenario. But, if you know the total and you can add stuff up, and, all the columns need to add up to the right, and the rows need to add up to the right, and the columns need to add down. So you'll be able to like fill in the information to just complete a table. And then you'll do one where it does, again, say find and interpret the marginal frequencies. So the right side is just going to be the total of whatever information is on the top row and the bottom row. And then the columns will be like the totals of, whatever they said. So you'll have a couple of those. Okay, then we're going to use this same information. Example, there were 220, it's kind of hard to read, but the total was 220. There were 220 students polled. So it gives you like this information all filled out, the two-way table with the marginal and joint frequencies. And then it wants 42 juniors, 77 seniors, 64, so on. Okay? Just a two-way table. Joint frequency and marginal frequency are just raw numbers. Okay? How many of them were juniors that said yes? How many were juniors that said no? 12th that said yes, 12th that said no. Just raw numbers. There's joint, marginal, and there's frequency like on all of them. Joint frequency, raw numbers. So I'm going to kind of just copy over, kind of small, but okay, so then we're going to introduce another term called joint relative and marginal relative frequency. Okay, so the question will, I'm doing the examples that are in the book. It says use the survey results from the first example, which I just did, to create a two-way table that shows the joint and marginal relative frequencies. Okay, so I'm going to use the same, I'll do this one like bigger. So yes and no. Okay, so we're going to do, remember, joint frequency is on the inside, so when we do joint relative frequency, that's going to go inside the squares. And when we do the marginal one, it'll go on the outside. Okay, so a joint relative frequency is the ratio, so it's a fraction, of the frequency that is not in the total row or the total column, but it's the total number of everything. So it's kind of like saying how many it's how many were 11th and said yes compared to the total. Not just the 11th, not just the like yeses, but everybody together. Okay, so if you go back to the joint relative frequency is there were 42 that said yes, that were juniors, out of 220 total. So it gives us 0.191. Okay, so this one would be 64 out of 220, or 0.291. Okay, and then 77 out of 220, and 37 out of 220. Okay, so another way that you could think about this, and I'm not going to copy down all the 11th and the yes, like part of it, but this is like saying 19.1% of the students were 11th graders and said yes, and 29.1% of the students were 11th graders that said no, and 35% of the 12th graders and said yes, and 16.8% of the students that were polled were 12th graders that said no. So all of those, if you do it right, should add up to 100%. Okay, so that's, kind of a way to like think about that. Okay, so that's joint relative frequency. Everything that I did like in red. Okay, then we have, and you're comparing. They call it like a relative frequency or a joint because it's 11th and yes, and it's 11th and no, and it's a 12th and yes, and it's a 12th and no. It's two things kind of in conjunction. Okay, and so then we have our marginal relative frequency. So we're going to create this other like box here. Okay, and it is just adding them together. Okay, so 0.191, 0.291 is 0.482, and then 0.35 and 0.168 is 0.518, and then the same thing like up and down, we'd say 0.541 or 0.459, and then again, just like the last one, the two like margins should add up to the total. Well, both of these should add up to 1 or 100%. Okay, because you could look at it again, if I convert this, 48.2% of the students polled were juniors. Remember, this is the 11th grade one. 51.8% were seniors. 54.1% said yes. 45.9% said no, they're not going to go. And it should add up to 100%. Okay, so the question again would say, find and interpret like the marginal relative frequencies. So I kind of just said it verbally, but in the what does this 48.2% mean? It means that 48.2% of the students polled were 11th graders. 51.8 were seniors, and so on. 54% yes, 45.9% no. Okay, so it's just a way to kind of organize like data to create like some reference points. So again, just to like summarize, marginal relative frequency, you do add the rows and columns. Okay. All right. So then you'll have a couple problems. Again, just to like fill in like a chart, or excuse me, it gives you to convert it to this. Okay. Use the two-way table to create a two-way table that shows joint and marginal relative frequencies. So we want to see the decimals. You don't have to do the bottom part if you don't want to, but you do need to do like this part. This is just kind of, I think, easier to read in terms of like, well, what do all those decimals like mean? And then it will give you, a couple of like problems to do to create your own table and like frequency stuff. Okay. All right, and then one last relative frequency and the marginal relative frequency. It's comparing like everybody together. It's like all of them. Where then when we say joint relative frequency and marginal relative frequency, it's like percentages, but it's percentages of the whole. Okay, like of everybody. How many were juniors that said yes? Of everybody. How many were juniors that said no? Of everybody. 12th graders that said yes, 12th graders said no. Okay, so this one is everyone. Okay, then, this one is I'm dividing the number of juniors by everyone to get the joint frequency, joint relative frequency. Okay, just joint relative and marginal relative is much broader. Relative means I want to know the percentages, so it's the numbers out of the total thing. Will be on conditional relative frequency. And I'll read you what it says in the book, and then we'll kind of interpret it a little bit different. But it's the ratio of the joint frequency to the marginal frequency. Okay, it's the ratio of the joint to the marginal. Okay, so if we go back and we use the same info, so we're not recreating the wheel here, but on this one I'm going to put the relative frequencies in, so like those decimals. So this one was 0.191, and this one was 0.35 and 0.291 and 0.168. And we actually don't need to know these bottom ones. Okay, and then this was 0.482 and 0.518. So this is, I want to show you this because this is how the book is like organizing it, and then I'll, I think, give you a way that makes a little bit more sense. So it wants to know the conditional relative frequency. It's the ratio of the joint to the marginal. So it's just the 11th grade one, or it's just the 12th grade one. Okay, so when we create this new info, okay, so this one would be like I should have made it bigger, 191 over 0.482. And it's 0.396. And then I'm going to do the same thing like on the no part, 0.291 divided by 0.482. So it's the same thing. It's the joint, ratio of the joint to the marginal. Remember, the joint is on the inside and the marginal is on the outside. So this is all joint and the marginal is that. Okay? And so this is 0.604. And then I would do the same thing on the bottom, 0.35 divided by 0.518, and I'd get 0.676. And then this is 0.168. And again, over 0.518, we use the same number, and we get 0.324. Okay, so what is this telling us? So in this, do a little bit bigger this time. In this box, we got 39.6%. Right, and then we got 60.4%. Okay, so what this is saying is this is just the junior row. So 39.6% were 11th graders. Of the 11th graders, 39.6% yes. Of the 11th graders, not compared to everybody, just the 11th graders. It's conditional. It's just the 11th graders. Okay, said no. Okay, so the other ones, when we do the joint, it's conditional. Just 11th, just 12th. There's a condition to it. Okay, so this one is 67% were 12th graders, and you're just comparing it to the other 12th graders. Okay? And sometimes they don't always work out. Oh, this was 676. I forgot to put the point on the 67%. 67.6%. So if you look at just 11th and just 12th, you'll notice that they do add up to 100%. Okay, so another way to I think it's much easier, but you're going to have to study the terminology. Conditional relative frequency. If we go all the way back to the beginning, so we had 42, and over here we had 106 total, and we had 64 that said no. And then for 12th, we had 77 that said yes, and we had 37 that said no, and we had 114 total. If you just do 142 divided by 106, you get 0.396, which is the same. So I think that way is much easier than doing all this decimal stuff. Okay, so this would be 77 divided by 114, 0.676. Okay, 0.324. So really what you need to comprehend is we throw in the conditional relative frequency. It's saying just 11th and just 12th because there's a condition to it. I only want to know about the juniors. I only want to know about the seniors. Okay? So the conditional part makes it a little bit more narrow. You're not comparing to everyone. Okay, in this situation, you're comparing to just 11th or just 12th. Okay, so that will help you to, when do I, do this one, I'm dividing the juniors by just the total number of juniors. Okay, so you got to kind of rationalize those two things. Conditional will narrow it down. Okay, like that's kind of the best way I think I can explain it. So again, it's a few problems of each type. Okay, and we'll continue to do some stuff with this tomorrow, but I think once you get the hang of it, it really isn't that difficult. So the key, I think, again, is the terminology, and conditional is just each group by themselves. If you can study that part and wrap your head around that, you're going to be dialed in perfectly. All right. Have a good Thursday, and we'll talk to you tomorrow.